Welcome everybody to the Kubernetes SIG network meeting for Thursday, May 26th, 2022. And let's see, I added the first item, which was Cubecon Recap. Anybody who went want to give a really quick summary and highlights?
We all pronounce paella wrong, and Ricardo's a clown.
All right,
Wait,
moving on.
I am what? Sorry, I was on the other meeting.
How are we supposed to pronounce paella?
Antonio?
Paella. Why?
Paella?
No. Paella.
Paella.
Right.
Antonio, Google disagrees with you, by the way.
Yeah,
I Googled it. Many places on Google disagree with you.
I mean,
This
does
is
it
the
depend
topic
on
of
what part
entire
of Spain
evening.
you're in?
Google knows more Spanish than Antonio, right?
I can agree. I mean, we shouldn't start again with this conversation because all of us know how this ends, and I don't want to start.
It ends with me getting hungry. That's what.
No. The problem is like, yeah, never mind. Right, Jim?
The value of Cubecon, the real value of going to Cubecon for anybody, well, that's not many people, but for anybody who is on the fence about ever going to Cubecon, the value is you sit around the table and you argue about stupid stuff like this and build a sense of personality from everybody.
Then you have in-jokes that everyone else in Signet doesn't get.
That's right.
Sorry.
We won't make any shower beer jokes. It was a good time. I feel much closer and more invigorated to everybody. So I really do. I encourage everybody who has a chance to come to Kubecon in Detroit. I would love to see you all there.
Absolutely. And I got to be on a panel with Tim and Lockie and folks. And probably the most invigorating part about that was the audience was full of questions. And they had some good questions and some good ideas and just things about, okay, cool, you have dual stack now, that's fine. Now here's a whole bunch of implementation details you might not have considered yet. So it's like, wow, okay, we've got our work cut out for us.
Anybody else wants to share takeaways from Kubecon? All right.
Okay, Sanjeev, multi-cluster network policy. You got a presentation, it looks like.
Okay.
All right, go for it.
You see my share?
That's a lot of tabs.
Holy moly.
I'm testing Chrome's ability to keep all that. Anyway, so yeah, we briefly started talking about this on the last call, and since we barely got started, I was asked to reserve 30 minutes. So I haven't actually myself paid any attention to this or worked on it. So there's a chance I might be forgetting a few things, but we'll wing it as we go, and hopefully we'll have enough to decide how to go forward. So I'm not going to cover. So by the way, any questions? Some people wanted some links on MCS API and things like that. I mean, anything before I sort of walk through it? Any high level questions or comments? No? Okay. So let me not walk through this list, but if needed, we can come back at the end. So we'll just sort of touch on 2 or 3 use cases. And the goal of today's presentation is mainly to agree whether this is worth doing and what are the primary use cases to be tackled. Oops. Okay. So the core questions include, how critical is it to add support for multi-cluster network policy? What is the community feel? Is this a high priority thing, medium priority, or a never thing? Should the feature be designed to cover both single network and multiple network modes of operation, or various kinds of multi-cluster operation modes? And just to briefly describe, when we say single network, we mean a group of clusters which are in the same routing domain. They don't need to NAT to talk to each other. All pods have unique IP addresses, and pods to pod traffic can work without going through any kind of NATing gateway. That's quote unquote the single network or flat network model. And multi-network model implies all pods are in their own routing domain, and they typically NAT to get out or get in. And so each of those are their own quote private networks, and pods have to go through some kind of multi-cluster gateway. And in order to have multi-cluster networking, and then does the policy have to work in that sort of mode? So do we need to design this policy to work in all such modes, or are some modes much more important than others? Okay. The third bullet is, should this feature be limited to models implied by the current Kubernetes multi-cluster services API? It's kind of got a reference model of cluster sets and namespace sameness and things like that, and exporting and explicit exporting or importing of services. Or should this work go beyond the model implied by the MCS API? Also, perhaps look at the future trajectory of the MCS API. Should this policy be within the scope of, if we are working within the MCS API model, should the policy be within the scope of a cluster set, or are we talking also multi-cluster set? So cluster set, as perhaps you may know, is a group of clusters over which multi-cluster services are distributed and are within the same administrative domains, so have the same set of namespaces and so on, at least as far as multi-cluster services are concerned. So should the policy also be within the cluster set, or should the policy be both within and across cluster sets? And across cluster set, you might call it like a multi-cluster set model, so which is sort of one more level of beyond just multi-cluster. And if you look at it in Istio-like terminology, they sometimes call that as multi-mesh. The other bullet is, what exactly is the admin model for multi-cluster that we want to address with this sort of features, right? What are we protecting against? And what is the admin model? Presumably we first start with a developer with a set of APIs that are targeted at the developer user. But then, what is the admin model and the developer model? And also what is the threat model that we are trying to solve? And then in general, we just need to continue to get use cases from people that are actually deploying multi-cluster apps as to what kind of segmentation and operational needs they have. So we've made some cuts at some use cases, but as we know, multi-cluster is still a new field. And then, things like policy for multi-cluster are also still very, early. So these are kind of core questions. Any quick thoughts on this, or should I get on to the use cases? Okay.
I have this, I have this lingering voice in my head that says, if multi-cluster network policy doesn't feel like plain old network policy, one of the two is wrong. I'm not exactly sure how to reconcile that, because I know some of the scalability issues, but I just want to put that out there.
Agreed. Yeah, maybe I should have put that in there. I've got some points at the end, which include, should this be just an extension of regular network policy? So the actual API details, is it the same kind, or is it a new kind? Is it semantically exactly like network policy, but just described? Yeah, so agreed with what you just said. Moving on, so let's look at some use cases. Some are perhaps more likely than others. Use case A, so this is a scenario. there's a cluster A here, cluster B here, connected with some arbitrary network in the middle. This particular picture implies the multi-network model, which we just alluded to earlier, which means that these pods are in their own CIDR, these pods are in their own CIDR, the CIDRs might actually be the same. So you have to go through some kind of gateway or natting operation. For now, we're calling it an MCS gateway after the MCS API. And that is what allows a pod in cluster A to talk to a pod/service in cluster B, even though the pods might actually have the same IP address. So, there are representations of the service and so on. So this is the more general case, which is the multi-network model. The single network model would be simply that there are no gateways. All of these pods can talk directly to pods in other clusters because they're all sitting on the same network, and the pods can straight go out and talk, right? So in here, the use case is assuming both single network and multi-network requirements and all kinds of topology should be supported. I have import from cluster B into cluster A. And here the import refers to the MCS API import, which is the next explicit export and import. But once I have imported it into cluster A, I don't want it to be usable by any pod. I want to decide that this pod doesn't get to access the imported service and this pod does get to access it. So I want to have some kind of egress direction multi-cluster policy referring to the imported service without needing to know pod IPs in the remote cluster, because as we said earlier, it has to work both in single network and multi-network mode. So we can't just put a policy, say, which, a CIDR-based policy, for example, which just looks for the remote IPs. So that's the first use case. So as we said earlier, this should work in all topologies. And from what our initial look at, it looks like this could be done within the scope of the current MCS API. So this sort of use case, if we want to address it, would not require an MCS API architectural change. In terms of feedback from the real world, I've heard of some early users of MCS where this kind of scenario was considered it is a use case that needed solving, which is egress policies that limit who can access services imported from another cluster.
So I want to call out a use case that I had to deal with a customer, where they sort of, against best advice, give individual cluster owners cluster admin permissions, but they don't fully trust those cluster admins, at least not in the multi-cluster sense. Like, do whatever you want within your cluster because it's your cluster, but now they're trying to stitch these clusters together into a multi-cluster model. And the problem that I see with a model like this is it depends on sender side enforcement, which that multi-cluster admin could just disable, right? Is there a component of server side enforcement also here?
So that's the other use case. So two comments on that. Yes, your point is valid. And the two comments are as follows. A, we have some other use cases for receive side enforcement. And B, one of the core assumptions of the MCS API is that the cluster set is a consistent admin domain. Whether these are separate admins or whether these are admins that are cooperative admins, let's just keep it simple and say it's a simple admin, because the additional requirement of the cluster set is that namespaces have to mean the same thing across all the clusters in the cluster set. And exports and imports are being done with an implied trust model. So the assumption is that there is a common trust model across these clusters. For the case that you're referring, where there is not an implied common trust model, either we have to decide that that doesn't fit into MCS or requires additional use cases, and we have to address that. So this particular use case is for the scenario where there is an implied common admin model, and enforcing on egress is effectively also protecting the service because it's all one admin authority.
So just jumping off there, even if I trust the admins, sender side enforcement means that a single cluster compromise, suppose you're running an app and it gets hacked, turns into a group cluster compromise, because I can just disable all rules from that cluster and now I can attack anything else in the network. Like, so it's not always a voluntary situation.
Agreed. So we may decide that just egress filtering is not enough, but of course this is just one use case that we can support, because if you do have the ability to enforce this, the benefit is that you drop the packet early. You drop it on the sending cluster rather than sending the traffic all the way to the receiving cluster, consume bandwidth, and then drop it, right? So if you have, you may want to additionally have receiver side filters, but to the extent that sending side filters are valuable because you're dropping it earlier in the sending cluster rather than the receiving cluster, and you actually get more granularity on the sending side, which we'll see, so the short answer is we probably need a combination of both sending side and receiving side clusters, and different cases have, so yes, we do need receiving side filters as well. This, I'm just breaking it down to one use case after the other so that we can decide. Yeah.
Let's not belabor it here. Let's push ahead. I want to.
So this is
I don't want to eat all your time.
Yeah. So this is the use case. Yeah. And this was something that some solution architects that I talked to who were working with customers identified as a scenario that they would like to see some kind of coverage for. Okay. So just not that we're going to define the API, but just to take a sample YAML, I've left the kind as TBD. Maybe the kind is the current network policy. Maybe it's a new one, whatever. But it looks pretty much like the current network policies. The only difference here is that on the egress, we've added a service import reference, or just a service import really, so that on the sending cluster, this would have to be an imported service to access. And we would say only pods that satisfy these match selectors and so on can send or cannot send to this imported service. So it could fit in pretty much with a semantic like today's network policy, maybe with the same kind, maybe with a different kind, but with the addition of additional selectors and filters.
One question, Sandeep. This imported service is a normal service, or these services that the multi-cluster thing uses?
So they are very much like they are normal services, but because of the way the MCS API was introduced as an opt-in model, you have to explicitly create service exports and imports of current unicluster services in order to turn them into multi-cluster services. And also there are some gotchas with what kind of operations are implied if a service has been exported on the look. So the short answer is that these are extensions of current unicluster services, but because of the explicit opt-in model of the MCS API, there are a few more subtle points which one needs to understand. So a service does not automatically imply a service import, but these are more or less the current unicluster services with an extension to multi-cluster. We'll come back to more of that. For now, think of it sort of like the current services. Sorry for a long-winded answer, but basically these are the current services, but require an explicit extension to operate in multi-cluster mode. I mean, yeah.
So okay. Is this import ref, is that multi-cluster service foo? Is that a combination perhaps of the cluster that this is in and the remote cluster, or is the service referring only to the remote cluster?
So the way the MCS, any implementation of MCS is supposed to work is that here I happen to have a service which was exactly this string. It was called multi-cluster service foo, right? I have not added any preceding text to turn it into multi-cluster. Somebody called it multi-cluster service foo with the intention of changing it to multi-cluster, but he first created it as a unicluster service in this cluster. And then he added a new API called service export that service. And then the controller today automatically turns those service exports into service imports in all the other clusters. So this cluster will see a new API resource show up without the user configuring it. It would be pushed by the controller to members of the cluster set, and he will see this service import. So that is his representation of a link to the remote.
Okay.
And so on his side, he says, okay, these pods are allowed to send to this service import, which shows up, and these pods are not allowed to this service import, which showed up.
And forgive my unfamiliarity with the details of multi-cluster services, but how does the service import show up in cluster A?
It shows up as an explicit new resource called service import.
Okay.
It does not automatically also create a quote unquote service object.
Okay.
Yeah.
Okay. I guess that's what I was looking for. Because I was just doing a quick thought experiment in my head, which was, I know we don't support services in network policy, but we're, in this straw man kind of proposal in the YAML, it's kind of doing services in network policy. So it's kind of like, if we support it for multi-cluster, why wouldn't we also support it for unicluster? And then at that point, could they both be the same thing?
Exactly. So this also has the implication of extending network policy to apply to services, which is another thing that has been sort of talked about frequently from time to time. Yeah.
But it also depends on the user, right? Like if our targeted user isn't the developer, then we shouldn't be doing it in network policy. We should be doing it in admin network policy, right?
Yeah, regardless of admin or regular network policy or both, there is that other issue which Dan just mentioned, which is that if we do this, then should we also do service network policy?
Yeah, definitely. I agree with that.
I mean, practically, like for a developer who's writing a network policy, who may or may not know whether they're going to be running in a multi-cluster environment, if we were to support something like this, they have to specify both, because they don't know whether they're allowing single cluster or multi-cluster, right? Like there isn't a way to express both unless we add a slight shim in between here that says, a service ref means service or service import, whatever your implementation supports, right? If we were to go down this road.
Yeah, there are some nuances about implicit versus explicit mapping between services and service imports. We don't need to go down that sort of path in this particular call, but as we go further, we can deal with that. But yes, there is that issue of potential synergy with regular services. Yes.
Probably too detailed to point out here, but would we want to do something like service selector instead of just a name? I know we're not at that point.
Yeah, we could.
Anyway, ignore that. That's for later.
Yeah, we could have labeled. I mean, here we could do match labels so that, yeah.
Yep. Okay.
Okay, so that was use case 1. Use case 2 is also an egress side control. Here, the requirement is if multiple clusters are providing this service, the client cluster should be able to control which providers of that service can be used by which client pods. So in this case, MCS foo is provided both by remote cluster B and by remote cluster C. They're all in the same cluster set. This is actually, in theory, a client could send to either cluster B or cluster C, but for administrative reasons, this particular tenant or application should be accessing this global service, let's say, only from this cluster B. So the admin here, or even the developer here, again, let's put it as, for simplicity, the developer persona, has a policy which says, okay, these points should only access this service from cluster B, maybe because of geolocation, or maybe because of latency, or maybe because of just an administrative policy. But it is more convenient for the enterprise to have multiple instances of the service all over the enterprise, because this is your, let's say, your global directory service or your global service, which is instantiated in lots of locations. But you want to administratively control that I want to get this service only from location 1 and 2, but not from location 3. So again, this should, if we want to address it, it should ideally work both in single network and multi-network topologies. It would appear that even this could be done within the scope of the current MCS API, with a little bit of due diligence needed there. And a few points to note there would be that, again, getting into details, in order to make this work, the combination, there would be some configuration requirements or restrictions. For example, here, what we're calling the gateway IP, which refers to the IP that the gateway exposes, okay, in the case of an MCS gateway, and the cluster set IP, which is essentially the analog of the cluster IP, but in the multi-cluster world. That combination needs to be unique per export, so that on this sending cluster, when he says, I want to go to this, this cluster set IP, the cluster DNS would come back when saying, okay, this multi-cluster service has this cluster set IP. If I didn't have the filter, I can go to any of these backends and I could load balance across these 4 backends. But I need to distinguish that, okay, I want to only go to this cluster set backends represented by this cluster set, and not backends represented by this cluster set. So I need the gateway comma cluster set IP for him to differentiate. I know that was a little bit of a detail, but anyway. So comments on this use case. The comments that, again, this is an egress side filter. We'll talk about the receiving side filter next. But this is to decide, to control which providers of a service you're allowed to use.
So is this to control for security reasons or for efficiency reasons?
It could be any number of things, typically some kind of administrative reason, okay? This application, let's say this application is specific to the United States geography, but I'm running in a global enterprise, okay? This could be my global, I want this application to only locate this service in United States clusters, some administrative policy like that.
Because it feels a little bit more like topology than network policy.
It feels like a daemon set for regions. Only talk to instances of this service in US East.
And a cluster set is all trusted, right? So it wouldn't be security in this case, right? If they're in the same cluster set, like for this use case.
I was initially, when you started presenting this slide, I was going to say, no. Like this MCS explicitly is designed not to encourage people to think about individual clusters, right? But if you sort of zoom out and look for a pattern, it's the same thing as traffic policy local, internal traffic policy local, right? It's just local means same region or same zone or something else. And I guess that's okay. I was okay with internal traffic policy, so I don't have a leg to stand on to say no to that.
Although it's not same, it's well, or it's not clear what the sameness boundary is, other than, right? Because in this case, cluster A and cluster B are considered to be the same, but cluster C is different or whatever.
I didn't get that C was different, just that you don't want A to talk to C because maybe C is in Asia and A is in Europe, and you don't want to cross that.
Right, but you do want A to talk to B. So there has to be something that explains in what way A and B are the same, but A and C are different.
Right. Well, Sanjeev, you mentioned something about like regionality, right? So maybe A and B are both in Europe, right? So like it's missing the indirection of the metadata here. It's not that A can talk to B, it's that A can talk to anything in Europe or something like that.
Yeah. So this use case came up. I was actually discussing multi-cluster scenarios with your colleague Nathan from Google, Tim. So he kind of suggested this kind of scenarios and a few others discussions as well, where the point was that it is very convenient to have global services provided from different locations, different kinds of clusters, some on-prem, some on. You should split these into two different kinds of global services as an alternate way of solving it, right? So you want to have actually that same service, it's running the same backend, but you have various kinds of administrative scenarios that end up popping up in practical scenarios. Some of them could be based on geography, like you were just saying. These Europe clusters should always go to Europe. Of course, there are geographical DNS. Also, the cluster DNS could also become sort of geo-aware and all that. But this could be the other way around also, that yes, I have a cluster in Europe that I could talk to, but this application needs to stay within my enterprise boundaries. So I need to only talk to clusters in Europe and within my enterprise. Whereas this application, I can talk to any cluster in Europe. It doesn't have to be within my enterprise. So there can be all kinds of administrative rules, which we may not always foresee. But the point is that global services are convenient. You still want to decide, I want to use these providers for this application and maybe the entire set of providers for this other application.
I'm not sure that I agree with, sorry, I don't know who I just stepped on, but I'm not sure I agree, but I want to point out that we're at 40 minutes and I know that there are some other things on the agenda too.
Okay, we can stop. Sorry, I tend to yak away, trying to be a little.
Rahul, did you have a question?
No, I mean, I just wanted to ask what the implementation mechanism for this is. My thought was that you're describing a pretty complicated routing scheme, and it feels like this extends beyond network policy, right? Like this sounds like something that just, if you have MCS in general, you might want to describe region locking or stuff like that, like independent of any security constructs. This sounds like a problem that maybe network policy doesn't want to be involved in. That's my instinct, because it sounds like there's interesting things to be doing here beyond just security boundaries.
So yeah, we could continue thinking about it. This has some similarities to various topology-aware routing sort of scenarios, but again, this is still an early look at the kinds of scenarios. Some of them may be appropriate to tackle, and some of them may require different functionality. We are just sort of throwing out straw man here about scenarios and then picking the ones which are more important to tackle first. Okay, we can stop here. Looks like, so just to show you what was remaining, we won't go into it. So there's another use case C, which is another kind of ingress control. Use case D was basically treating multi-cluster as unicluster in every possible way. So do everything in multi-cluster that you can do in unicluster, but that typically would imply that it only works in the flat network model, not in the multi-network model. So if we decide that maybe this primarily only needs to do the flat network model, there is also that other thing, which is you do everything in multi-cluster that you can do in unicluster, including CIDR prefix and so on. That's one thing. I've got a note on various other use cases, which, please think about it. And yeah, so basically just trying to get agreement, what are the use cases, and then decide the priority of working on it.
Thanks. I want to encourage us as we look at this problem, like it is a hard problem, and let's not lose sight of what we really want just because of what we think is possible. We've done the impossible before. We can consider doing it again.
I added an item to next meeting to possibly continue this. So if you're around for next meeting, Sanji, if we can keep going.
Yeah, and the document is public, so please feel free to add comments. Yeah, we can continue.
Okay, thanks. All right, next up, Swetha, kubelet refactor by default.
Yeah, so I think I've spoken to Rob, and it kind of sounds like the community and Signet might already be aware of these issues. There's also a fix, so just to kind of catch everyone up, there was a refactor in 122 that changed kind of pod lifecycle. Essentially, pod shutdown takes longer than before, so in situations like node evictions or pod evictions, what happens is the pod doesn't have time to complete its shutdown, and it ends up that the pod doesn't report its status. And then it goes away, and then kubelet kind of doesn't know what happened to the pod, but so the pod goes into this unknown state, but it's never deleted. Because of this, our endpoints controller and endpoint slice controller doesn't consider the pod as terminated and then keeps the endpoint alive and keeps it in the service resources. So there is a fix I think Antonio put. I just wanted to make sure people were aware of the issue, and then also wanted to see, will we be able to backport this up to 122?
And I have another news for you. There is another bug with with the shutdown.
Oh, really?
Yeah, but this one is related to probes, and I didn't have time to address the comments. So if you can, I know Rob added some of the comments, Clayton added. I will work tomorrow or for next week. It should be ready. And I mean, I think that we should port it to 122. It's breaking a lot of people. I agree. Saw three different issues today that are, seem related. The other bug that I want to, so is this one. Let me show you. The other bug related to this. Let me paste it in the chat. But this is about the when the pod is being deleted, they weren't showing the status. I couldn't follow up on it, but so if the bottom line that I want to say, if you see weird things with pods being deleted or ready or unready, just raise it because it has to be related to all these changes in the kubelet.
I also want to second Bowie's point in the chat that we should probably improve our testing around this. I know we have some, I think I talked to some folks in Signet and they pointed us to some restart tests and reboot tests, but maybe we need to add a little bit to that so we could catch things like this.
But the main problem here is we are consumers, and the SIG node, and this SIG node should have tests for this. So the main problem is that what I understood for talking with Clayton is that until 122, the life cycle was buggy. So you can have a pod fail and it return to be ready and things like that. So it's not that we should have tests, and I'm adding regression tests for this. But my perception is that all the SIG node life cycle of pods is not well tested.
Or documented.
We should have these guarantees. I had to pull all the people in Qcon to understand the life cycle, and that's, you see, nobody has it clear. And I think that the rest of the projects in Kubernetes will grow, work around in all these life cycle things, everybody interpreting one thing or the other, and we have this.
So I have a question. Like, should we have a cap? I don't know. I know it's not designed, but just to cover this, and then also have the node folks to just basically lay out like, this is the pod lifecycle. We're going to document it. We're also going to add tests, kind of thing.
I talked
Just
to
so that's
Creighton.
like a good documentation trail.
I talked to Creighton when I was debugging this bug, and he told me that he was writing a cap, but I don't.
Oh, he is.
He told me that, but I mean, I don't know.
I see.
I don't know at this point.
Yeah, because we might be doing the same. I would love to dedupe the effort.
I mean, what we need is the cap and the test asserting the cap. So all the rest of the project doesn't have to test something. You know, we cannot start testing things that should be granted. If the pod life cycle is like that, we need to assume that it's like that. But nobody knows.
Should we reach out to Clayton because my next step recommendation for Sweta was just to put a proposal for like documentation and tests and conformance. But I didn't. If there's multiple people doing the same thing, we should just work on one thing.
I don't know. Right now, I don't know in SIG node who is handling this. But what we need to do, and I'm going to fix this bug at a regression test. I need to check the other with the probes. I need to add another regression test. Andrew is on leave, right? Because Andrew had tests for the readiness thing that we don't have. We need to check, and we are not testing too. Okay. Okay.
Okay, so I will send out a cross post on SIGNode and SIGNet just to sweep up if anyone else is working on this, and then we can discuss kind of how to make this more robust.
So, well, the thing is, we need SIGNode to define the pod life cycle, and we need that. And once we have that, we can add the test in SIG network. Because if we start adding tests and we don't have it documented, we are working in parallel and we can drift. I think that's the better way of moving here.
Okay.
I don't know if somebody disagrees or not, but I don't think that now start adding tests is going to solve anything.
Okay. I think that's all I had for this topic. I think the next one is also me.
Go for it.
So as I was debugging some of these lifecycle issues, I noticed it's very difficult to kind of isolate our controllers when you're looking through the logs. I wanted to see if people would be opposed to kind of adding some context logging, at least to our controllers. So that would be endpoint slice, any others that people are interested in. And do we need a formal KEP for that, or?
What do you mean by context logging?
Just to kind of add like a key on the like logs, so that way you can filter. So you could say like endpoint slice controller or endpoint controller, and you can kind of filter that out a lot easier. Right now, there is no filter once you get into the Cube controller manager. Like you get, I think some data you get is like the line number and then the file name,
So
which isn't very easy.
The
so
JSON
part of
thing.
Sorry, Antonio, go ahead.
No, I was going to ask you because you were with Patrick working on that. The JSON thing wasn't supposed to fix this. This structure logging.
It's supposed to enable this.
Okay.
So now when like the idea was early on in the life cycle, when the controllers are all spawning off, you can add metadata and says, this is the logger for the endpoint slice controller. This is the logger for the foobar controller. And then that gets annotated on every log line. And that way you can do this sort of filtering. So Sweta, I think the short answer is yes, we should totally look into it. That's what the structured logging is supposed to enable. Okay. It's not free, right? If you do that, every single log line gets annotated. But if it's valuable for visibility, then that's what it's for.
Tim, if we did this unilaterally, or do we need to coordinate with like whoever owns the home for all the controllers, like the controller manager?
I don't know if anybody else has started on this process. If not, I think we can be the pioneers and say, hey, we're going to decorate some of our controllers to work this way. And if it looks like it's successful, we should encourage others to follow suit. If others have already started on this path, then we can follow their lead. Sweta, do you know Patrick?
I'm assuming. Sorry, go ahead.
Sweta, do you know Patrick? He's been leading a lot of the structured logging stuff.
No, but I can definitely reach out if you can give me a Slack.
Just put his name in the chat.
Okay, perfect.
Sorry, Bowie, do you want to say?
Oh, I was just going to ask, like, worth a mini cap, or we just send PRs?
I would just open a PR and see if anybody really wants a cap on it.
Okay. Thank you. I think that's all from me.
Bridget, next up for multiple node site or cluster.
Yeah, yes, right. Thank you.
Node IPAM.
So yes, thank you. So this one, I didn't really have it on my radar of things to pay attention to for 1.24. So I apologize for not being in the mix and helping with that. But it looks like we are going to be pushing that one forward to 1.25 or beyond. And I started chatting with Cal about what still needs to happen. And I started looking at this. It looks like there was a draft PR to do some of the code work. And I'm kind of wondering, does anybody else have this one on their radar as something that they're interested in working on? It kind of looks like the person who wrote 109.090 maybe hasn't responded since March. So yeah, just kind of wondering what people's thoughts are around this one.
It looked like that one needed to address Cal's comments, at least. I think Cal had quite a few comments there.
Absolutely. So like there's forward. Yeah, so there's two things there. There's the docs and whatnot that needs to happen for the original thing that got kicked out of the release. I can help with that. But then I'm looking at this stuff and thinking, do we have somebody who wants to work on taking over that PR if that person doesn't come back, basically?
So that person is a Google person, and we can go stir that. And I don't think they're abandoning it. I think it was simply, the cycle of the release force them to go focus on other stuff. So we can go poke them. It's definitely something we want to push forward.
Also,
okay, awesome.
He was just on vacation for all of May. So the lack of responses, he's just, been out of the office.
That's great. I mean, it's great that he's on vacation, and it's great that he's not completely on a different project and not caring anymore.
No, I mean, it's definitely on his radar. I asked him about it earlier in May, and once he's back, probably like first week of June, after he's probably cleared out his inbox or something, he can start getting back on that.
Awesome. I think we'll probably be in a little bit of a race condition if we're going to try to get this into 1.25, we might end up missing that in terms of the enhancements deadline. We can try, but it sounds like if we are going to get movement on it started in early June, then we might get it into 1.26, which, is fine.
Yeah.
What's
let's not leave it. Let's not leave it to the end. Sorry. Go ahead, Rob.
Oh, what's the deadline we're missing? Sorry,
I'm just looking at the Kubernetes release deadline for 1.25. And so like the enhancements deadline for 1.25 is in early June. So if this contributor isn't able to start working on this again until June, that's fine. It just means we might not make 1.25.
Well, the enhancement was already cleared. The enhancement was cleared for 24. So we should be able to carry that forward, right?
The cap's
Maybe, I hope so.
A couple of cycles. We've just keep kicking the implementation itself down the road.
Oh, totally. And I'm just looking at this this draft PR and going, wow, adding 13,995 lines of code code and configs and removing 69 lines. Okay. I mean, that's cool, but that's a lot for people to review, of course.
That Tim's is cool.
Tim needs to break out his, here we go.
No, but I think that is only missing the implementation. So the only deadline that we care about is the release.
Okay. Anyway, I'm going to be attempting to make sure this one gets in, but I'm happy to know that the Googler who was working on that is still in the mix and going to be coming back to it. Thank you.
All right, Rob, Gateway API.
Cool. Yeah, this is a quick one. We are hoping to get V050 out very soon, hoping for a release candidate sometime next week. V050 is important because it includes some beta graduation, including gateway class, and HTTP route. There's almost no change between V1 Alpha 2 and V1 Beta 1 that we're proposing here. But I wanted to just have one more call out. If anyone from SIG Network wants to review this, this is a good chance before we commit to it, because once things go to beta, it's hard to change them. There's a link to the PR. The PR is really just a diff from what we released as V1 Alpha 2 to V1 Beta 1. We have a few little things working in response to feedback already on that PR. But if you care about Gateway API, if you want to give feedback, we'd love to have it. But the time window to give that feedback for this release is running out. So yeah, that's all for me.
Okay, thanks. And we have a few minutes left. Is there anything else that's not on the agenda that we should talk about?
Just that Tim appears to have a new spaceship.
I'll shift them every week.
Red Hat had some code launched. Well, I guess my office had some code launched into space yesterday on the SpaceX rocket. We had like a launch party and everyone had the spaceship background, but it was pretty cool. So
awesome.
There's some micro shift running on a satellite up above our heads right now.
That's awesome. Congratulations.
Yeah. Wasn't me, but it was cool to be in the same team.
Very cool.
And everybody send much love to all our VMware colleagues who are in a meeting which may be very challenging for them right now. So
much love. And also, if there is sadness, all the rest of us would love to have you come do this exact same meeting, but wearing our jersey instead.
All right. Thanks, everybody, and see you in 2 weeks at this time. All right. Bye.
Thanks, everyone.
I'll pop in later this afternoon just to see if anybody shows up.
I'll try to as well.
All right. Cheers, everybody.
Bye.
Cheers. Bye.